In this session, we'll take a look at integration by substitution. The objectives here are to evaluate integrals by using the substitution method. Before taking a look at the substitution method, let's review some formulas. The first formula is the power rule of integration, which says that u raised to the power of n du is equal to u to the n plus 1 divided by n plus 1 plus the arbitrary constant. The second formula is the integral for exponential e, which says that the integral of e raised to the power of u du is equal to e raised to the power of u plus the arbitrary constant. The last formula is the formula for the integral of a natural log. It states that the integral of 1 divided by u du is equal to the natural log of the absolute value of u plus the arbitrary constant. Now let's take a look at how these formulas are used in substitution. In this first example, we're asked to integrate 3x squared times the quantity x cubed plus 1 raised to the power of 10 dx. When using the substitution method for integration, we simply try to rewrite the variable. Normally we use the variable u in substitution, so we try to rewrite the x variables as u variables. Note that 3x squared is the derivative of x cubed. Therefore, we can substitute u equal to x cubed plus 1. Remember that the goal here is to rewrite any x variable as a u variable. The second step, we'll find the derivative of the substitution equation. So we'll take the derivative for both sides of the substitution equation. When we take the derivative for the left-hand side of the substitution equation, we have du dx. When we take the derivative for the right-hand side of the substitution equation, we have 3x squared. The third step will solve for du. In solving for du, we'll simply multiply both sides of the substitution equation in which we just found the derivative. We'll multiply both sides by dx. So we have du is equal to 3x squared dx. Our next step will now rewrite the equation with the variable u. Recall that we substituted u for x cubed plus 1, so we're able to rewrite this portion as a u. We also found that du equal to 3x squared dx, so we can write 3x squared dx as du. So now we've transformed our previous equation into the variable u. We now have the integral of u to the 10th power du. For our next step, we'll integrate. We'll find the integral for u to the 10th power du by using the power rule, which gives us u to the 11th power divided by 11 plus the arbitrary constant. Notice that our original problem contained the x variable. So in order to change our u variable back to the x variable, we have to do what's called back substitute. Recall that we substituted u for x cubed plus 1. So we'll simply back substitute u into the previous result, which gives us x cubed plus 1 quantity raised to the 11th power divided by 11 plus the arbitrary constant. Let's take a look at another example. Here we're asked to integrate the natural log of 3x dx divided by x. Remember, the goal in substitution is to write any and all x variables as u variables. Note that 1 over x is the derivative for the natural log of 3x. Therefore, our very first step will substitute u for the natural log of 3x. The second step will find the derivative of the substitution equation. So we'll find the derivative for the left-hand side, which is u. We'll find the derivative for the right-hand side, which is the natural log of 3x. Once we find our derivatives, the derivative with respect to x for du is du dx. The derivative with respect to x for the natural log of 3x is 1 over x. We'll now solve for du. So in order to solve for du, we'll multiply both sides by dx. Now we're able to rewrite the equation with the u variable. Recall that we substituted u for the natural log of 3x. We can also substitute dx over x for du, which gives us the integral of u du. Next, we'll integrate the integral of u du by using the power rule, which gives us u squared divided by 2 plus c. Recall that our original problem contained a variable x, so now we'll back substitute. Recall that we substituted u for the natural log of 3x. Once we back substitute that into the previous result, we have the natural log of 3x quantity squared divided by 2 plus the arbitrary constant. In the last example, we're asked to integrate x times e raised to the power of x squared dx. Notice that 2x is a derivative of x squared. Therefore, in the very first step, we'll substitute u for x squared. We'll now find the derivative of the substitution equation. So we'll take the derivative for both sides. The derivative with respect to x for u is du dx. The derivative with respect to x for x squared is 2x. In this case, we'll solve for x dx. We'll simply divide both sides by 2, and we have 1/2 du is equal to x dx. This will allow us to rewrite the equation with the u variable. Recall that we substituted u for x squared, and we solved 1/2 du is equal to x dx. Therefore, we can rewrite our equation to variable u as 1/2 e to the u du. Next, we'll integrate. We'll integrate 1/2 times the integral of e to the u du, which gives us 1/2 times e to the u plus c. Now we'll back substitute. Just recall that u is equal to x squared, which gives us a final result of 1/2 e raised to the power of x squared plus the arbitrary constant. Thanks for watching.